Hi, everyone. I'm Elias Kouki, professor at INCYBER, and I really appreciate your invitation to give this talk about the detection of DDoS attacks in IoT-based environment. So I started the talk by a brief introduction about 5G and the surface attacks, and after that, I will survey some existing works and the limitation of the state-of-the-art works. After that, I will give an example of our contribution in our laboratory. And after that, at the end, we conclude the presentation. So we know that 5G will lead IoT technology to be omnipresent in many connected environments. So imagine, for instance, that 5G actually can reduce the latency time from 200 milliseconds in 4G to just 1 millisecond in 5G. So the reduction time or the latency time is reduced by 200 times. So also the bandwidth or the data rate is increased by more than 10. And also the spectrum is more covered. And so for this reason, we strongly believe that the 5G will put like a revolution in the networking technologies. For instance, in the case of vehicular communication, do you know what is the average time for a human reaction? For instance, when we see in the road verglas or any accident, events, etc., do you know what is the average reaction for a human when he visualize something? The average time is 250 milliseconds. It's quarter than a second. So in the context of 5G, this will be ensured completely by your equipment, because the response time or the latency time is reduced to just 1 millisecond. So this is very fabulous. This means, for instance, when you are driving cars, so you don't need really to maybe to make your reaction, because the system will do it for you. And the system will do it very, very fastly. We are speaking about 1 millisecond, it's very high. It's very, very optimized. So yes, we know that new connectivity means new business models and also new opportunities and new services, etc. So we have also to note one thing, that the 5G will increase the number of connected devices by 100 compared to the 4G in the same surface. So in the same surface, we can connect more than 100 IoT devices. So this is really fabulous. So yes, this is good, but we have just to note that the 5G will increase the attack surface. We are not speaking about only the end user surface attack, but we are speaking about end-to-end from the cloud to end user device. So the surface attack really will be very, very increased. So the attacks can be achieved from the cloud to the end user, but also from the end user to the edge, and also the penetration can come from the edge. So, and also according to the Nokia recently has achieved one study and asked more than 50 network operators around the world. So around 70% of these operators admits that their 5G network are very vulnerable to attacks. So we imagine that 5G is more secure, but the reality is not. Yeah, according to this study achieved by Nokia, more than two-thirds of network operators around the world are very vulnerable to attacks. So, but in the context of IoT, the vulnerability is increased. Why? Because we know that depending on the application, for instance, if we take the IoT based on vehicular networks, etc., so every IoT device usually is equipped by 2 or more than 2 or 3 interfaces, wireless interfaces. And some interfaces are open, like for instance, in the case of IEEE 802.11p, so every device has at least 2 interfaces and has at least 1 control channel and 4 service channels. All these channels are very open. This means that every attacker can penetrate and can put or can realize the attack. This is what happens a few months before in the model of Tesla, for instance. And yeah, this is from one side. From the other side, we know that some IoT devices are very limited in terms of resources. So we cannot deploy any intelligent intrusion detection system in order to mitigate attacks, for instance. So we cannot, for instance, deploy a deep neural network in order to detect attacks, etc., in IoT devices. This is really not applicable because of the limitation of the resources. So all these reasons come to the conclusion that the future for 5G-based IoT or IoT-based 5G are vulnerable networks to attacks. So at the consequence, the result of that we'll have attacks related to the cybersecurity and other attacks related to the privacy. For instance, in the future, it will be easy in order to track the identity of vehicles, and after that to trace its trip, and also to get its identity, etc. So we know also that when we speak about 5G, we are speaking about multi-layers, and all these layers are vulnerable to attacks, from the physical to the network to also facilities. This is what we call application services. So 5G, like 4G, in terms of attacks, we can find several attacks related to the CI services, like availability, confidentiality, integrity. And when we speak about the availability, one common attack is what we call DDoS, or the distributed denial of service attack. So even in a 5G, we can realize this attack very easily. But the issue, the difference between doing DDoS attack in simple IoT environment or 5G environment is really, really different. Why? Because in 5G, we have a strong data rate. So at the past, in order to achieve one, like a DDoS attack with like 1 terabit, an attacker has to take like 1,000 and 1,000 and 1,000 of zombie machines. Currently, we don't need this. By 5G, each machine can send like a data rate of theoretically until 1 gigabit, more or less than that. So using just 10 machines, so you can do like very famous or very interesting attacks against very several DNS servers on the internet, etc. So this means that the 5G, yeah, 5G is very fabulous, but also 5G will be like a vector of attack that attackers can realize. So we have also like confidentiality attacks that we can, for instance, we have here a reply attack that we can achieve on confidentiality. And also we have the what we call false data injection attack that we can realize on integrity. So in practice, all what you can imagine in terms of attacks applied in a sample IoT or in a sample 4G, so they can be applied also in the context of 5G. So almost researchers in the context of detecting attacks are like here. So some researchers are interested by detecting attacks and studying the behavior analysis using machine learning or supervised and non-supervised machine learning. Some other works are interested by more aspects related to the confidentiality and integrity, etc. And some other researchers are interested by the how to ensure or how to secure the privacy in the context of connected environments. So now, after having speaking about like the state of the art, what exists in terms of attacks, etc., but how to prevent these attacks. So the first key in order to prevent this, in the case of 5G-based IoT or IoT-based 5G, so is to improve our understanding to the attacker behavior. You know, in the past, the attackers, so in the past, we achieved some operations based on artificial intelligence in order to study the evolution of the attacker operations. In the future, these attackers are using and will use artificial intelligence in order to follow our methods in order to detect them. So really, we are speaking about the like a confrontation. So until now, we use AI in order to detect them, in order to detect attacks. In the near future, the attackers are using AI in order to study our, like, how to detect them. And this really will be like a very, very challenge. So the first, I think, key, in my opinion, in order to ensure efficient and secure 5G environment is to understand the evolution of attackers and how they see us. So the second way also is to develop an innovative supervised and non-supervised machine learning for detecting, but also for predicting attacks. Like the majority of works in this area are interested only by detecting, but the real innovation is how to predict them, how to predict these attacks. And the third element also is to design a new attack-resilient algorithms in the context of 5G environment. So in order to mitigate attacks, technically speaking, some researchers are using machine learning supervised. Other researchers are using machine learning non-supervised algorithms. And the other ones are using isolation technique based like a network operator isolation, etc. Like when we observe the routing process and when we detect malicious behaviors, so we can isolate them. And otherwise are based on simulation studies or so this is just what is the difference between supervised and non-supervised. I guess they are expert in the area. So usually when we speak about supervised learning, so we are taking into account like a data set, and we base on this data set in order to see at the output of if we have like this behavior is an attack or not. So in the non-supervised, unfortunately, we don't have this data set. So to our opinion, the majority of works are suffering from at least one of this limitation. So some researchers are dealing by like local detection and not end-to-end detection. Some others are only limited by only one attack. We can find some solutions like how to detect DDoS. Some others how to detect man in the middle. Some other research how to detect false data injection. But really, we don't have like generic approaches in order to detect several attacks based on their signature or based on their behaviors. So some other research also are suffering from scalability, and the other ones are like not really in not respecting the standards expectation issues. For instance, as I told you, the 5G, we are waiting for the solution that can give a response in only 1 millisecond. And you, if you are expert, if you develop like a deep neural network solution in order to get like zero, false negative, etc. So it's good. But the first element is that you have to respect the expectation. Your solution should give a response time of at least around 1 millisecond. If your solution give like a response time like in 1 second, this is not good at all. So it can be applied in some other environment, but not in 5G or IoT-based 5G. So when we respond to all these limitations, we are really building the bridge between the industry and the research community. So we have a lot of research that we are doing in our laboratories, but usually speaking, so are based only on simulations or on some theoretical, etc. And the industry are very observing in terms of standard expectation. So I think that the collaboration between these two communities maybe can lead to the alleviate the issues related here. So I will give you here an example of our contribution that we developed in our laboratory. So how to detect or how to mitigate DDoS attack in end-to-end manner. This means from IoT to the cloud and using like multi-layer hierarchical environment. So this is the architecture we developed in order to detect or to mitigate DDoS attacks. So we considered a big surface attack composed of various end user devices like vehicle, cameras, IoT devices, etc. So at this level, this is what we call access layer. So we collect information, and after that, we give them to the MAC layer or to the edge. And also, this is like one specificity or another specificity of 5G compared to 4G. In 5G, we will use the edge in order to give this a very short time response. So, and we give this decision to the MAC layer, which is also what we call the fog, or what we call also the edge. And after that, we will report the decisions in the cloud. So this is like the operational operation steps of our solution. At the beginning, we collect the information and the log information related to the end devices. After that, we operate them and we deal with them in the module what we call analysis. And after that, we apply a Markov chain in order to predict the state T+1. So the Markov chain that you know gives the future state only based on the current state. We don't need to observe the historical or the history data. Based only on the current state, we can like predict the next T+1. So and after that, we apply a reaction model in the cloud based on blockchain. So here we develop a smart contract blockchain in order to trace and to save the behaviors observed from each end device. So yeah, these are the steps as I told you. So I have just to note that we considered here 3 behaviors. We considered the authentic behavior. This is when the device is operate like honestly. We have also another behavior suspicious. When, for instance, a device try to delete information at the end. And also, we have a malicious behavior. So when a user, for instance, or when end device or when IoT device tries to delete like some activities in the server or in RSU, right side unit, in a road, etc. So we report this device as like malicious activity, and we block it directly, and we report the ID of this end device on the cloud, and after that, we update our access list mechanism or our authorization mechanism. And so other ways, if the activity is not related to the to delete, but just to read, so in this manner, we apply our Markov chain model, and after that, we predict the next state or the next state of the end device, and after that, we report it in the cloud, and we can block the device if we observe that the end that the activity is within the high risk. So those are the four ranges we considered here. We considered that when device is authentic, when the device is honest, and after we considered also two ranges of suspicious activities, and the red one when the user is 5 minutes? Sorry. And this is 5 minutes?
Il reste une minute. One minute.
So, sorry. So this is the Markov chain we developed here. After that, so I go to the thorough mathematics. So these are our reaction that we deployed in the blockchain. This is the smart contract we developed in the cloud. And so these are the results we obtained here. So our results have been published in the IEEE Network magazine and also in the IEEE Transactions on Network Science and Engineering. So, okay, at the end, I have just to note that we are developing research from considering the pre-attack phase, under-attack phase, and also post-attack phase. So, thank you so much, and if you have any question, please let me know.
Merci, vous pouvez l'applaudir. Yes, Cookie, I hope you have a lot of questions. The first questions, please.
So, sinon pas de questions, je vais juste peut-être clarifier un point ici, rajouter un point. So, I said, sorry. So, in the moment you don't have any question, I can give you maybe just 1 minute, please. So, as I told you, here we developed a new reaction algorithm. So, this reaction algorithm are based on blockchain smart contract, and these smart contracts are deployed on the cloud. Why we deploy them on the cloud? Because in the cloud, we have like a big capacities of saving, of execution, etc. And these algorithms are very high in terms of computing. So we cannot save them or we cannot execute them on the end device. This end device is very limited in terms of resources. So we chose to execute them on the cloud, and after that to spread the results to the end device.
Merci.